Hi everyone, my name is Levi Feucht. I am part of the Walleye Safe Operating Space project up at Trout Lake Station. And my summer research has been looking at the changing dynamics of yellow perch in McDermott Lake. So a little bit about me first. I am going into my 5th year at UW-Madison as both a biochemistry and wildlife ecology major. I'm from a small little town that's south of Fond du Lac called Eden, Wisconsin. And this is my 3rd summer that I've been through Trout Lake Station. The last 2 summers I've been up on station, and then this year I'm working remotely here in Madison. And then outside of school and work, I'm a very avid outdoorsman. Lots of hunting, fishing, camping, hiking, any way I can get myself outdoors. And I'm also a big sports fan, so I'll be watching every Brewer game that I can. I'm a big fan of the Packers and the Badgers and things like that. But my work with the Walleye Safe Operating Space project the last few summers, I've been a field research assistant and am working on my capstone research for this project. Then I also had the opportunity to give a poster presentation at the 2020 Wisconsin American Fisheries Society Conference, which was up in Eau Claire. And then also through Trout Lake, I've just been doing independent research, primarily focused on yellow perch and how they've been adapting to this project. So some background to the Walleye Safe Operating Space project. In the past years in Wisconsin, especially Wisconsin in the North Woods and things like that, we've been seeing an increasing number of warm water fishes, specifically largemouth bass and sunfish. Meanwhile, populations of cold water fishes such as walleye have been decreasing. And walleye are very popular fish to the North Woods. They bring in lots of tourism, lots of people like to go fish for them, and they're very popular at fish fries. A lot of people like to eat walleye. And we're seeing a decreasing number of these number of very important fish in North Woods lakes. So the purpose of this project is to see if a removal of these warm water fishes now will open a window that these cool water fishes can rebound their populations, or if there's something bigger going on that these populations are declining, such as climate change or other factors like that. So in order to conduct this research, we've been doing a fish removal on McDermott Lake, removing fish like largemouth bass and bluegill. And for this data, we've removed more than 100,000 fish from McDermott Lake. Meanwhile, while doing this, we've also been using Sandy Beach Lake as a reference lake, where we're just monitoring it and seeing how fish populations there are reacting while not doing anything to the lake. And both of these lakes, McDermott and Sandy Beach, can be found in Iron County, Wisconsin. But curiously, yellow perch have not been removed, as yellow perch are a cool water fish and not in the same family as bass and sunfish. And I find yellow perch very interesting in the system, as they're in the middle of the food web, where they're both a prey item for the larger predatory fish in the lake, while also preying on small fish. And I was curious as to see how they'd respond to this changing environment around them with lots of fish being removed. And in order to conduct this research, we've used a variety of different gears on the lake to catch fish and to study the populations. So up in the top left, we have a clover trap, which we use for catching small fish in the lake. And little fish will be baited to swim through little slits that we have in the sides between the lobes, and they'll be stuck in this trap. And then we pull them and we can count them and things like that. On the top right is an example of our crew out electrofishing one night. And when we electrofish, the electrofishing boat has large anodes that go down into the water, sending out a charge. And as fish are brought in towards this charge, they become stunned, and then they'll float up to the surface where we can catch them. And then we put them in a live well, we process them, and then we can return the fish to the lake if they're not something that we're removing, such as yellow perch. And then on the bottom, we have examples of fyke nets. We have smaller fyke nets, which are used for catching small to medium-sized fish, and then the larger fyke nets, which catch a lot more of the larger fish. And what a fyke net is a net line that runs out from shore, where we have a float line on top that floats on top of the water, and then a line down on the bottom that sits at the bottom of the lake. And typically at night, when fish are moving along the shorelines, they'll hit this line, and then they'll follow the netting line down into this larger box. And then once in the box, it's sort of like a funnel-like system that gets these fish caught further down into the net. And then once they're caught in the net, they cannot get back through the funnel. It's a lot harder for them to swim through. Some will be stuck in the net, and then we can empty the net and count and process the fish that are in them. And then this figure looks at the catch per unit effort across all the gears on both lakes, all 4 gears that I've mentioned. And the catch per unit effort is weighted so that an electrofishing run where we're going for 30 minutes is weighted differently than one single clover trap, so that we can compare them for the same amount of effort that we put into each and see how catches are going across each different gear and compare them. So on the y-axis, we have that adjusted catch per unit effort, and then on the x-axis, we have the 3 different years. The graphs on the top, those 4 represent the McDermott traps, and then the graphs on the bottom are the traps at Sandy Beach, where we're not doing a removal, and we're just leaving this as a reference lake. And then we have it broken down by the different colors and kind of the columns between the 2 lakes so that we can compare them between the clover traps, electrofishing, the larger fyke nets, and the mini fykes. And then what I have highlighted here is what we found statistically significant, that the catches over the clover traps, electrofishing, and the large fyke nets in McDermott Lake, the catches of yellow perch in these traps has been increasing over the years. And although the graphs in some of the other areas may look like there's more change going on, it has not been found that to be statistically significant in those, given the possibility of lack of data or other factors going on. But we have found significant change across these 3 traps on McDermott Lake as removal is progressing in yellow perch. Then this graph breaks down the length to age relationship across the lakes for the yellow perch. And length age graphs give us a visualization of how the fish are growing in the lake year to year, how much they can grow in a year, what the largest fish in the lake might be, and how old they are. And as you can see, based on the graph on the right for Sandy Beach Lake, Sandy Beach has larger yellow perch than McDermott. McDermott has a lot of small fish and the lake is very stunted. So with too many fish in the lake, these fish don't have enough resources where they can eat enough and grow larger, and they're confined with a lot of other fish. And another one of the goals of our project is that with some of the removals of a lot of these fish, a lot of these largemouth bass and bluegills, we'll start to see some of this stunting be alleviated and the fish will grow larger. Well, what we've seen so far between the length and age distributions is that we're not seeing a large change in that yet, but what we are seeing is a much larger number of catches of year 1 and year 2 yellow perch on McDermott Lake. So this indicates that recruitment for these fish and reproduction is doing a lot better, and that the young of year yellow perch have a much better chance of making it to year 1, and then a much better chance of making it to year 2, and that we're seeing a lot more reproduction in these fish. So the numbers of yellow perch are maybe starting to fill this gap that's made by a lot of the removals. And then in this graph, we're looking at the weight and length comparison for both McDermott and Sandy Beach. On the bottom, we have length in millimeters, and then for the y-axis is weight in grams of these yellow perch. And again, you can see that Sandy Beach has larger fish. But one thing to really note about Sandy Beach is that across the 3 years, the trend lines have really been very similar. 2017 with less data is a little bit shifted, but we can really see that 2018 and 2019 are about perfect with each other. And then looking at McDermott, we can see that 2017 and 2018 are incredibly similar to each other, while in 2019, we're starting to see a slight increase in the weight at a certain length. So this means that a fish caught in 2019, if it were 200 millimeters long, may weigh 5 or so grams heavier. So this could be indication that these fish are eating more and that they have available to more food resources. And this could be happening due to the removal of a lot of other fish. And And we're hoping that this could also be the start to stunting being alleviated in the lake, and that the yellow perch that are left in there, as well as the other fish, may be starting to grow larger. So in summary of the findings, yellow perch are a remaining fish in the lake, curiously in the middle of the food web, so they are hit by a lot of different dynamics of the lake. And we're seeing increasing catch rates across multiple gears on McDermott Lake as the removal is going on, as well as an increase in the numbers of age 1 and age 2 yellow perch. And we're also seeing a potential increase in the length and weight relationship. This could be the start to stunting alleviation, the start to a lot of these pressures coming off the fish. And all of these results happen after only 1 year of removal. So with something like fish populations in a lake, we're not going to get immediate results. But with the removal in 2018 and now 2019 and 2017 being used as a baseline year, we're starting to see some trends happening with the removal. And there is also current ongoing removal. We had about 100,000 more fish removed in 2019. Removals are happening this year, 2020, up on McDermott. So we hope to continue to see a lot more trends, and it'll be interesting to see how the lake responds to this large removal effort. So I'd really like to give a big thank you to Jack and Pat Lane, without whose funding I would not be able to be doing this amazing work and research through Trout Lake Station. I really want to thank you for the funding this summer. It's a blessing to be able to work as part of this group and be a part of the Trout Lake family again, especially through tough times such as this. And then I'd also like to thank the Juday family for also giving funding to other fellows and the work that they do with Trout Lake Station. And I'd like to thank Trout Lake Station, the Center for Limnology in Madison, UW-Madison, and also UW-Stevens Point, who also does work with us with this project, like fish processing and removing some traps. A big thank you to Holly Emke, the grad student on the project, who is leading the project and heading all of us working on it. And she's been a great help and a great leader over the years. I'd like to thank Ellie Anderson, the current tech on the project, who I had the pleasure of working with last year. Thank Joe Murnack, the fellows advisor, who's helped me a lot with this project this summer, and the Wisconsin DNR, who has helped us with our work on the removal. So thank you, everyone. It's a fantastic pleasure and opportunity to be able to work in a project such as this. And again, I'd really like to thank Jack and Pat Lane and the Lane family for all the funding and the work that they do to give students like myself the opportunity to work at Trout Lake Station.